Welcome to surveying presentation on the topic compass surveying. Group members Utkarsh, Anshuman, Bhavna, Siddhant and Subhranshu. Question 3.1. Explain the different components of a compass. Compass. A compass is a small instrument essentially consisting of a graduated circle and a line of sight. The compass cannot measure angle between two lines directly, but can measure angle of a line with reference to magnetic meridian at the instrument station. The components of a compass differs as the type of the compass we are using. As compasses are used for different purposes, hence their components differ accordingly. This is an image of the scaling of a simple compass. This is an image which shows the different components of a simple compass. Now to the description. Base plate. It is a hard flat surface on which the rest of the compass is mounted. It has a ruler on its edge for measuring distances on maps. Its edge is straight and useful for laying lines on a map. Scale. Each edge of a compass may have different rulers for use with different map scales. Direction of travel. Arrow marked on the base plate. You point this the way you will be traveling. Magnifier. For seeing small map features better. Index pointer. Butt end of the direction of travel arrow. It ends right at the edge of the dial and is where you take degree readings. Dial. Ring around the housing that has degree markings engraved. You hold the dial and rotate it to rotate the entire housing. Declination mark. Used to orient the compass in an area with known declination. Orienting arrow. Marked on the floor of the housing. It rotates with the housing when the dial is turned. You use it to orient a compass to a map. Orienting line. Series of parallel lines marked on the floor of the housing and on the base plate. Needle. Magnetized piece of metal that has one end painted red to indicate north. It sits on a fine point that is nearly frictionless, so it rotates freely when the compass is held fairly level and steady. Housing. Main part of the compass. It is a round plastic container filled with liquid and has the compass needle inside. Bubble. A bubble of air in the housing liquid is useful for making sure you are holding the compass fairly level. Sight. Improves aiming your compass at distant objects. Question 3.2. Explain magnetic, true, arbitrary and grid meridian. These consist of geographic poles, magnetic poles, true meridian, magnetic meridian, arbitrary meridian and grid meridian. Geographic poles. Earth has two geographic poles, the North Pole and the South Pole. They are the place where the axis of rotation meets the surface of the planet. The north geographic pole of a body is 90 degrees north of the equator. The south geographic pole is 90 degrees south of the equator. Magnetic poles. Our planet also has two magnetic poles, the north magnetic pole and the south magnetic pole. The magnetic poles are near but not quite in the same places as the geographic poles. The needle in a compass points towards a magnetic pole. The magnetic poles and geographic poles misalign by a few hundred kilometers. This is an image showing the difference between the geographical meridian and the magnetic meridian. True meridian. True geographic meridian is the imaginary circle on the Earth's surface terminated by the geographic north and the south pole. The position of a point along the meridian is given by that longitude and its latitude measured in angular degrees north or south of the equator. Each meridian is perpendicular to the equator. Each is also of the same length. Magnetic meridian. The magnetic meridian is an equivalent imaginary line connecting the magnetic south and north poles and can be taken as the horizontal component of magnetic force lines along the surface of the Earth. Therefore, a compass needle will be parallel to the magnetic meridian. Arbitrary meridian. Sometimes, for small area, a convenient direction is assumed as a meridian known as the arbitrary meridian. Sometimes, starting line of survey is taken as arbitrary meridian. Grid meridian. For preparing a map, some state agencies assume several lines parallel to the true meridian for a particular zone called grid meridians. The bearing with respect to the grid meridian is known as grid bearing. Next, question 3.3. Explain the difference between prismatic and surveyor compass. This is an image of prismatic compass. Prismatic compass. Main parts. Magnetic needle. It is the broad form symmetrical with rider weight to remain horizontal. Graduated ring. Aluminium graduated to half minute with 0 on south end. Object vane. Metal frame hinged for folding with a vine with vertical thread or wire. Prism and eye vane for taking reading of the ring agate cap and pivot on which the ring and needle move. Box and glass. The assembly is set in a box and has glass cover on top. Lifting lever lifts the needle off the pivot to reduce wear and tear. Brake pin to reduce the oscillations of needle. Screw head to screw the compass onto a tripod. Reading the prismatic compass. The reading is taken from the prism end. When the line of sight is in the direction of magnetic meridian, the reading must be 0. The reading is done at the south end and hence the 0 is marked there. Prismatic compass gives whole circle bearing. The ring is marked with 0 at the south end and up to 360 degrees clockwise. Surveyor's compass. This is an image of the old form of surveyor's compass which is not commonly used right now. Main parts of the surveyor's compass: needle, graduated bearing, pivot, eye vane, object vane, lifting pin, lifting lever, and glass cover. Comparison between prismatic compass and surveyor's compass. Prismatic compass has a broad needle, whereas surveyor's compass has edge bar needle. In prismatic compass, ring moves with needle, whereas in surveyor's compass, ring is fixed to the box. Prismatic compass, the graduation is from 0 to 360 degrees clockwise, whereas in surveyor's compass it is 0 degree at north and south to 90 degree at east and west in 4 quadrants. Prismatic compass measures whole circle bearing, whereas surveyor's compass measures reduced bearings. In prismatic compass, the numbering is inverted, whereas in surveyor's compass, the numbering is erect. In prismatic compass, eye vane and prism is used for reading, whereas in surveyor's compass, eye vane is not used for reading. In prismatic compass, the reading is taken at the south end, whereas in surveyor's compass, reading is taken at the north end. The prismatic compass can be used handheld, whereas the surveyor's compass is to be used with a tripod. Next, question 3.4. Explain WCB, QR and reduced bearing and their relationship with an example. Whole circle bearing or WCB. The horizontal angle made by a line with the magnetic north in the clockwise direction is the whole circle bearing of the line. This system is also known as the azimuthal system. In this system, only the north direction is used as reference meridian. Whole circle bearing can take any value from 0 to 360 degree. This is an image showing the whole circle bearing system. In the figure, theta 1, theta 2, theta 3 and theta 4 are whole circle bearing readings. Quadratic bearing or QR. The horizontal angle made by a line either in clockwise or anticlockwise with the magnetic north or south, whichever is closer from the line in the eastward or westward direction is the quadratic bearing of the line. This consists of 4 quadrants: northeast, southeast, southwest and northwest. Reduced bearing. When whole circle bearing is converted to quadrant bearing, it is known as reduced bearing. This is an image showing the reduced bearing. Relationship between whole circle bearing and quadrant bearing. This is typically of 4 cases. When the whole circle bearing is from 0 to 90 degrees, the quadrant is northeast. When it is from 90 to 180 degrees, the reduced bearing becomes 180 minus the whole circle bearing reading and quadrant is southeast. When the whole circle bearing is from 180 to 270 degrees, the reduced bearing becomes whole circle bearing reading minus 180 degrees and the quadrant is southwest. And finally, when the whole circle bearing is from 270 to 360 degrees, the reduced bearing becomes 360 minus whole circle bearing reading and the quadrant is northwest. This is an example. Convert the following whole circle bearings to quadrantal bearings. From the previous slide, we already know the formula to convert the whole circle bearings to quadrantal bearings. Using that, we can calculate the respective quadrantal bearings for the equivalent whole circle bearings. Next, convert the following quadrantal bearings into whole circle bearings. Similar to the previous problem, by using the formula, we can calculate the whole circle bearings of the respective quadrantal bearings. Question 3.6. Convert the following whole circle bearings to reduced bearings. First 77 degree 30 minutes, next 270 degrees 45 minutes. We know there are four quadrants, namely northeast, southeast, southwest and northwest. For each quadrant, there is a particular relation between whole circle bearing and reduced bearing. The relation goes like this, which has already been mentioned in the previous slides. So using this relation, we can easily evaluate and convert the following whole circle bearings to reduced bearings. Case A. Given whole circle bearing is 77 degree 30 minutes. Since it lies between 0 to 90 degrees, so the reduced bearing is the same as the whole circle bearings, which is north 77 degree 30 minutes east. Case B. Given the whole circle bearing is 270 degree 45 minutes. Since it lies in between 270 degree to 360 degree, that is in the northwest quadrant, so the reduced bearing becomes 360 degree minus the whole circle bearing, which is north 89 degree 15 minutes west. That's all, and thank you for listening patiently to this presentation.